Hello, good morning.
Good morning, ma'am.
Good morning,
morning,
ma'am.
Morning, ma'am.
Good morning, all. I hope you all are taking care of your health and social distancing protocol.
Yes, ma'am.
Okay, so I'll share 2-3 screens now, and then I'll mute all the participants. Okay, can you see this?
Yes, ma'am.
Simple linear regression problem. Okay, we have already discussed simple linear regression problem. We have calculated the slope and intercept. So today we will this is a problem we have already discussed, weight and height. So you are going to predict based on the, this is the x and this is y, and you are going to predict the value. So what we did here is we have taken the average, we have we have calculated slope and we have calculated the constant beta 0, and then we got the equation. So this is the equation y equal to mx plus c, where we have calculated this intercept using this formula, y minus y average, x minus x average, the square of this value, product of x minus x average into y minus y average divided by this. And then we have applied LINST function of Excel, which gives us the same intercept. So you might have now, it was step by step we are going through this. We just want to interpret what we are getting and why we are taking the average and why the error is so important. Because otherwise calculation wise or coding wise, it is straightforward. So that is what step by step we are going to discuss this. Now till now, why we have taken this x minus x average or y minus y average is, let's say this is your dependent variable. So this dependent variable is, I am taking average of this y minus y average. Why? Because I want to find out how much variance is there in my predicted variable. How much it is variated from the average. So this is minus 2.9. That's what these values are important. How is the data spread? What is the variance in the data? So with respect to x, this is x minus x average. So I'm finding out the variance in x with respect to central tendency value, so that I can further, whether my line is the best fit line, I can predict it only with the observed value and the predicted value. So observed value, how much it is variated, how much it is deviated from the original value. Observed value is the original value. Observed value is the value which is already observed by some observation or which are already recorded by experiments, and then we have formed the model out of it. Right? I am seeing only the number of participants are less.
There are 48 into ma'am.
Okay, I'm seeing 21 now. It has changed. Okay. 48 participants.
It's into
49.
Okay. So this best fit line gives me what I'm not going to find out. I'm going to find out the error. I'm going to find out the variance. How this variables, two variables are closely related, and this I can find out using the residual error or sum of square error. That is what I have taken first the variance of x value, then square of this variance, and then I have calculated for calculating this x1, beta 1, I am taking the product of x minus x average divided by the x minus x average ka square. So now I got this equation, I got the constant, and then I apply it with the LINST function. Now LINST function gives me what? If I use a inbuilt function, it has the range of y, range of x values with the beta 0 as calculated or constant. We have already discussed this. So if I keep that beta 0 calculated value, as we have already calculated it using this. So we have calculated the beta 0 value as 61.727 and we kept that value. So we got the intercept as 1.41. And with slope as 0, we got the value at 2.32. So using LINST function, we got the same equation and we plotted the graph. Now you want to analyze this. So to analyze this, you have to go to data. In data, you have data analysis tab. In data analysis tab, click on regression. And okay. Now in this, you are going to select the y range and you are going to select the x range. Y range is your dependent variable. So this is your y range. Then you are going to select x range. This is your x range. You can select label or you can select include label. So it takes the labels over there. Now output option may, okay, output range though it is same. Now this is important, residuals. So here I am using residual plots, standardized residuals and line fit plot. The line fit plot is the one which we have already drawn with the calculated value. Residual is now the observed and predicted ka difference. So residual is observed and this may how much it is variated. This is the plot of the residual plot. And standardized residual is, it's like standard deviation. How much there is a deviation in the error which we have got through the residual. So I click OK. Now I'll get this type of plot. Now this is my best fit line curve, weight over the height. So this is predicted height. So it is pretty correlated with each other from the graph it shows. And now this is the residual error. The error from the predicted and actual. This is the graph of, this should be scattered one. Your error should be, it should not show some pattern in the errors. If it is linear, if the error should be, we'll see this in analysis in details. So if it shows some pattern, then it might not be a linear problem. We have to solve it with a non-linear problem. Right now, all the residual errors are scattered. So your predicted and actual output is you have got the best fit line for this. Now, if you see this, I have already calculated it with the. So what analysis we got after the detailed analysis? We got the analysis in 3 tabs, 3 sections. One is regression statistic, then ANOVA, and finally the equation. Now this regression statistic first is multiple R. This is what the correlation coefficient. The same question I have asked you in quiz also. So this gives you your 2 variables, height and weight, how strongly they are correlated. So how strong 2 relations are, this can be given through this multiple R, 0.977. So it has a very high correlation. R square is what? This is a coefficient of determination. I am not only relying on correlation coefficient, but I want how change in one causes change in another. It is not only the correlation. I just want a change in X value. Is it causing a change in Y value also? So is it handling the variance or not? So that gives me the R square value. It is same as what we got the cross product of the observed and the predicted. So error that which we got, uska square will give you the R square value. Adjusted R square, this is actually required for multi-variate equations. So it is not required at this stage for this. It has calculated it based on one equation. Standard error is again, hello, can you listen to me? Okay. Standard error is like a standard deviation. So it how precise your predicted line with the actual line. So it is like a standard deviation, but this deviation in terms of errors. Number of observations here are 10. And I just want to see any. Now this gives you the degree of freedom, sum of square. All the values might not be important at this stage. Okay, this is sum of square. So all the errors which we have got from the predicted and actual, iska sum of square is this. This is MS is sum of square divided by the degree of freedom. So if you see this, this upon this gives you the MS value. F is the null hypothesis. If you remember in second and third unit, we have applied the hypothesis. So your basic assumption and significance F is your P value is this, which shows that it is significant with this null hypothesis. So you are going to accept the null hypothesis. It means that whatever the prediction, whatever the best fit observed value, we are closely related to your actual values. So this is your ANOVA statistic. This is your residual, and this is what the equation which we have got. So this is the coefficient which you have got. This is the X variable, and this is what the predicted. Now this is just the equation is B17. So this coefficient plus mx plus c. So this is your coefficient, and this is your intercept into the X variable. So X variable into the coefficient gives you the predicted value. So if I just want to predict the value for the weight 56, so if you go to this, for this weight 56, the actual observed value is 138. Now we'll just see what the value is calculated using your equation which you have got. So for this, I put this value into the equation, and what I got is 143.795, and actual value is 138. So what is my residual? What is my error? Error is observed value, the actual value 138 minus 143.79. So your residual output is, now see this, this is all the residual predicted output using your best fit line which you have already fitted for, and this is the residual error. Residual is, now I have copy pasted this original value from here, the height, and I have just, this is the residual value which is given by the Excel equation, and I have what I did, it is just I have subtracted this value minus this value. So I have got the exact same values, exact same residual values over here. So this shows that using the Excel and using the calculated values, the residual values are same. And this is what the residual square, R square value. This is your R value and this is your R square value. Okay, so this is what you are observing, the predicted value with the actual value with the error terms, and this error we want to minimize. So if this error is minimized, we are saying that your equation is the best fit equation. Now this is your residual value jiska I have plotted a graph, and this graph is what it is showing a scattered pattern. Means these are all the errors which are calculated with the predicted and actual. These are not showing any pattern, means these are uncorrelated. It can handle any type of data and it can gives that. It is not correlated with the previous one or the next one. That is what it is not showing any pattern. If it shows any pattern, it means that it is not a generalized fit model. It might not be a best fit model. I need to upgrade it with the non-linear or classification or any other type of. Okay, so this is what the simple linear regression, the analysis. Simply you have to go to data, select the data analysis tab, and in data analysis tab, select regression. Similarly, you have covariance, descriptive statistic, histogram, moving average. So various options, t-test, and same thing is there in Python code. Why I am showing you Excel is, if I show you this, same you are going to apply it for your Python for your mini project. And again, the same thing, you will use a LM function and you will get all these plots over here, analysis over here. So again, your job is to find out what is the correlation, is there, what is the R square value, what is the predicted value. Residual is very important. Is there any variance in the residual, and how I'm going to use linear regression for this. Right, so this is about the single univariate linear regression. Now we will see the multivariate regression. Is it okay?
Yes, ma'am.
Now another example, simple example for multivariate. Now multivariate is more than one independent variables which are going to be used to predict the uh, dependent variable. Now in this case, again a simple example I have taken. There is a study of 10 students. This may the student test score, as I gave you the example previously also, the multivariate is more than one independent variables are there which contributes for the prediction of pi variable. As I said, ki for don't scratch. As I said, ki if I want to find out whether a student is likely to place or not, multiple variables are required. His active score, his logical score, his logical reasoning, soft skill. So multiple attributes contribute for the prediction. Similarly, the basic example here I have taken is IQ and study hours. These are the two independent variables which combinedly gives you a test score. So this is your Y and this is your X. So you are going to find out beta 1 and beta 2 over here. So again, same thing, go to data analysis, select the output range, select the X range. Now here the input range is IQ as well as study hours. Now you will, I want to plot all the 4 plots for this. So you got the multiple plots here along with the regression analysis. Now the analysis is, this is the summary output. Again, same multiple R, this is here. R value correlation. So there is a strong correlation. This is a square. So predicted and observed and predicted का difference का square. Adjusted R square. Then standard error. It is error में how much deviation is there. So 3.8, which is pretty marginable, and number of observations. Similarly, this is the ANOVA analysis, sum of squared. Then we have taken the ratio of sum of squared with degree of freedom. Significant F value 0.02. This is the null hypothesis value, that is 33.44. And these are the residual values. We got now here we have used the two independent variable, IQ and study hours. So what we got for this is the coefficient for IQ, which we have got is 0.5094, and study hour is 0.4671, and this is the intercept. So what will be our equation is y equal to 23.156 plus 0.50943 into IQ, the values of IQ, plus 0.467 into study hours. So your equation would be this, and based on that you will calculate the predicted test score. So with this equation, this is what the predicted test score. This is the residual, observed minus predicted का difference, and this is the standard residual, which is the deviation from the error. So this is the deviation. Now if you see the plots, we'll see the okay. This is the residual plot of IQ, residual plot of study hours. So all the errors are independent. There are highly uncorrelated. There is no pattern. So errors are acceptable. The model fits, gives you the best result. This is the line IQ line fit plot, and this is the study hour line fit. So study hour and test score are highly correlated. There is a strong correlation, and similarly the IQ and the test score. This also gives you the pretty strong relation. So this is for multilinear regression problem. The same I have already. So this is the study hour interpretation. So your equation, as I said, is 23.1.56 plus this into 467 into hours. So why we are interested in this equation, how you are going to relate it with your mini project or any assignment which you are going to do is, you are going to give the different test samples, and then you are going to calculate the values, and then you are going to see the residual plot. So if your residual plot is giving you the multivariate independent plot, scatter plot, then your equation is best fit. So whatever your claim, your null hypothesis is proving that your claim is your model is best fit for the multivariate equations. So another example which I have taken here is the basketball example. Here here the height, weight, goals, free throws, and average point throws, it's given. So you are going to predict the height based on weight, goals, free throws, and average point. it's a example with, I'll share this data sets with you so that you can draw some inference out of it. So you are going to predict based on these values. So I have already calculated. See this. This is the correlation. It is pretty less than the previous examples. We have taken this simple examples. Now here the number of observations are 251. So 0.72 only. The R square is 0.5 just on the margin. This is the adjusted R square. And standard error, though standard error is less available. And these are the intercept. Now for this 3 intercept 20. So I'm getting the 3 intercept values, 3 coefficient beta 1, beta 2 and beta 3. And these are the intercept. So based on this, these are the various plots which we are getting. Now this is the predicted, and this is the residual error. So you can keep here, you can copy again the test samples and then you can check. So supposing so this way you can plot, even you can plot a graph of this versus this, and then you can find residual representation, residual error representation. I have already, okay. This is with respect to variable. Now if we can infer from this is not giving you a linear train. If you see the height with this holds with this, neither of this problem is giving you a linear train. And if you see if I just draw the residual plot, now it is the scattered one. So problem can be solved using linear, but here the problem is multicollinearity. So that is not a part of our discussion right now, but multicollinearity can be one parameter which could be further explored. If you are getting a, though the values are lying over here, though here the error is minimized, some patterns if you observe like this, you cannot take this as outliers. So again, a multicollinearity. Okay, you are not able to listen to me. This is a problem with my connectivity.
Breaks the voice.
Hello? Hello?
Yes, ma'am.
Is it audible now?
Sometimes it's audible and sometimes it's completely breaking.
Completely breaking. That is the problem with my area actually, I think. Okay, so again I'll explain you. This is the Hello, now can you hear me?
Yes.
Now, this is another example. See, the discussion of today's is linear regression, calculating the residual, then finding out the residual error, and then finding out the plot of the residual error, so that we should be able to apply a proper fit model for any problem. Data as an data analyst, I should be able to find out which model fits for which type of application. Like in next units, you are going to study classification or logistic regression. So can I solve the problem using simple linear regression, or even though my models shows me a linear trend, is the error, residual error, giving me some different pattern? If it is this, then I should solve the problem using non-linear. So this way, classification is, am I going to apply the binary classification? Am I going to have a binary labels? Am I going to get such data where I'm able to predict the, even though there are multiple labels, I'm able to convert it into binary classifier? If that is there, I am able to apply a model for that application. So from data analysis point of view, look at this subject. That is what this simple application, though it seems to be very simple, the analysis is important to interpret. So in mini project also, or in assignment also, output you are going to get in Python, but you are going to write, you are going to comment, you are going to document the inference which you have got. What is the residual error? Is my residual error and calculated error is same? Is my R square giving me the scatter plot? This is what the is my correlation. Even though there is a correlation, since we have seen in the basketball example, the correlation is less. R square value is more less than the correlation value. It was giving for 0.5 only. So this is my inference, which I can infer from the required data. Now this is another mobility and density data. This way you are going to find out the mobility. Now if you see, I have already done this. So I'll just show you because 10 minutes are there only. So same thing, you go to insert, you go to data and analyze it. So now here I am getting correlation as 0.95. It means that there is a high correlation. I'm getting R square 0.92. It is not like basketball data. Just me, I got the less R square value. This is the adjusted R square value, and standard error here I am getting as 160.85. Now why this might, even though there is a strong linear relation. Now if you see this plot, you are getting a strong linear relation between these two, density and mobility. But standard error which I am getting here is 160.85. So this can give a thought to my linear regression. Should I try with non-linear regression? Here the regression, the degree of freedom, the SS, MS value I have got, intercept I have got. This is a single linear regression problem. Density I have got. So if I put the equation, my equation would be 1073.77 plus 336.670 into the density values. Now I have got the predicted mobility value. This is my predicted value. So I have just copied the observed value and predicted value, and I got this residual. So calculated residual and the calculated by your Excel formula, this gives me the same. Standard residual, these are my standard deviation in the errors. So this I have got. Now if I plot a graph of this standard residual or a residual, I am getting this. If you remember here in data analysis, if you want to see the standard residual, this is for the finding error. You click on this standardized residual plot. Then only you are able to view this. So in this, I am getting this type of plot. So if you see this residual plot, and I am getting some pattern in the residual error. So if I am getting some pattern in the residual error, means There might be variance in the data itself.
और आप जिस नाते की बात कर रहे हैं मैं उसी दिन आ जाता जिस दिन महाराज शांतनु ने देवव्रत से मेरी कठिन के राज्य में डाल दिया था तब मेरे आसमान के घाव का उतार मेरे सीने का लोगों की बात और आज दिन आ गया है महाराज हत्या परिवारों को कदापि आमंत्रित न किया जाए होने के नाते
Ma'am, we can't listen to you.
Nothing is audible now.
Excuse me, ma'am.
Hello, can you give the attendance right now?
Yes, ma'am.
So you can,
Yes,
I am
ma'am.
recording it. So at least in 1 minute, only 1 minute is there. So please, I'll record my lecture and I'll send you the link instead of this. The same lecture which I have taken, I'll record.
Yes, ma'am, that would be better.
Okay, ma'am.
Yes. You please answer your roll number and name.
Attendance.
Yes, attendance, please.
Ma'am, are you taking roll number wise or
No,
we
no,
should
you,
tell
yes, roll number wise or other, roll number wise, please. Roll number and name.
Guys, start calling. Roll number
Saying
wise
your
call
name, Sriram Mehta. Sorry, please start in sequence, please.
Is there anyone from 1 to 10?
Afra Sheikh, roll number 4.
Akash Rathod, roll number 5.